Far beyond the planets, beyond the fading reach of sunlight, lonely spacecraft continues its endless journey through the dark. Voyager 1 is no longer simply a machine built by humans. It has become a symbol of exploration itself, carrying humanity's curiosity into regions no civilization has ever touched before. And now, decades after leaving Earth, it is sending back signals that are changing how scientists think about the very edge of our solar system. This story does not begin in a distant galaxy. It begins much closer to home, at the invisible frontier where the influence of our sun slowly gives way to the enormous environment of interstellar space. That frontier is known as the heliopause, a turbulent region where solar forces meet the pressure of the galaxy beyond. When Voyager 1 launched in 1977, its original mission was straightforward. It was created to study Jupiter and Saturn, capturing close-up images and scientific measurements never before obtained. The mission transformed planetary science. The spacecraft revealed violent volcanic eruptions on alien moons, intricate planetary rings, and atmospheric systems unlike anything previously imagined. But Voyager's greatest journey began only after those missions ended. Instead of shutting down, the probe continued moving outward into the unknown. Year after year, it traveled farther from Earth until, in 2012, it crossed one of the most important boundaries in human exploration. Voyager 1 officially entered interstellar space, becoming the first human-made object to move beyond the heliosphere, the giant bubble formed by the solar wind surrounding our solar system. Scientists once believed this outer region would be relatively calm. The expectation was simple. As Voyager moved farther from the Sun, solar influence would gradually weaken while interstellar conditions slowly took over. But the spacecraft began detecting something unexpected. Its instruments recorded unusual changes in magnetic activity near the heliopause. These were not random spikes or isolated disturbances. The fluctuations appeared organized, repeating in ways researchers did not fully anticipate. Instead of a quiet boundary, the edge of the solar system seemed active and dynamic. Under traditional models, magnetic conditions near the heliosphere's edge should remain fairly stable, shaped mostly by interactions between the solar wind and the interstellar medium. Yet Voyager's measurements suggested a more complicated reality. The magnetic environment appeared to shift in structured patterns, almost as though enormous unseen forces were influencing the region. Researchers have proposed several explanations. One possibility is that powerful events elsewhere in the galaxy, such as ancient supernova shock waves or distant stellar activity, may be disturbing the interstellar magnetic field. Another idea suggests the heliopause itself constantly changes shape, expanding and compressing under pressure from surrounding interstellar material. Some interpretations go even further. A few scientists have questioned whether these magnetic fluctuations could reveal large-scale interactions between enormous regions of space, where magnetic structures connect and reshape each other across vast cosmic distances. In simple terms, Voyager 1 has forced researchers to ask a deeper question. Is the edge of our solar system truly a fixed boundary, or is it part of a much larger interconnected system that humanity still does not fully understand? The spacecraft cannot answer that question directly. What it provides instead is raw data, fragments of information hinting that this distant region is far more complex than expected. Subtle variations in plasma density, changes in energetic particles, and repeating magnetic signatures all point toward a boundary that behaves less like a wall and more like a constantly evolving transition zone. Meanwhile, Voyager 1 itself continues operating against all odds. Built with 1970s technology, the spacecraft is now more than 23 billion kilometers from Earth. Every message it sends travels for over 20 hours before reaching scientists on our planet. Communication is slow, fragile, and increasingly difficult. Yet the probe still delivers valuable measurements from a place no human instrument has explored before. Some scientists now describe the heliopause as semi-permeable rather than solid. Instead of completely separating the solar system from interstellar space, it may allow particles, energy, and magnetic fields to pass back and forth in complicated ways. If true, this means our solar system is not isolated. It exists within a constantly changing galactic environment shaped by forces far beyond the Sun itself. Another theory focuses on the structure of interstellar space. Vast filaments of plasma, formed by ancient magnetic fields, could be flowing past the heliosphere. As these structures move, they may stretch and compress the outer boundary of the solar system, producing the strange patterns Voyager continues to observe. Of course, many researchers remain cautious. Voyager 1 was never specifically designed to study interstellar space with modern precision. Its instruments are old, limited, and operating far beyond their intended lifespan. Some scientists argue that the unusual readings may eventually prove to be natural variations not yet fully understood. Even so, the persistence of these anomalies is difficult to dismiss. The patterns continue appearing in ways that suggest structure rather than random noise. As more data arrives, scientists are paying increasing attention to how the heliosphere interacts with the wider galaxy. In this sense, Voyager 1 is not simply crossing into empty space. It is traveling through a massive transition zone where the outward force of the solar wind collides with material drifting between the stars. And perhaps that is what makes this mission so extraordinary. Voyager 1 reminds humanity that the outer solar system is not silent or simple. It is active, layered, and still filled with mysteries waiting to be understood. Every signal from the spacecraft represents humanity's first direct glimpse into a region once thought unreachable. Some researchers even believe that, over time, Voyager's observations may help reveal larger magnetic structures spanning enormous parts of the galaxy itself. But for now, the probe offers only clues, scattered pieces of a much larger puzzle still hidden in the darkness beyond our solar system. The spacecraft will never return to Earth. One day its instruments will finally go silent. Yet it will continue drifting through interstellar space for millions of years, carrying humanity's first message into the vast ocean between stars. And maybe that is Voyager 1's true legacy. Not just the discoveries it has made, but the realization it represents. That even the edge of our solar system is not an ending. It is only the beginning of something far larger, more connected, and far more mysterious than we once imagined. Beyond the heliopause, the universe continues endlessly outward, waiting to be explored. The farther Voyager 1 travels from Earth, the stranger the silence becomes. Out there, beyond the planets and beyond the fading pressure of the Sun, space is no longer familiar territory. There are no worlds nearby, no bright sunlight, no comforting sense of direction. Only darkness, radiation, and the endless movement of invisible cosmic forces. Yet even in that emptiness, Voyager 1 continues detecting signs that interstellar space is far more active than scientists once believed. For decades, astronomers imagined the space between stars as mostly empty. A cold vacuum scattered with thin gas and drifting particles. But Voyager's journey has revealed something very different. The region outside the heliosphere appears structured, shaped by magnetic fields and streams of plasma moving across enormous distances. One of the biggest surprises came from changes in cosmic ray activity. As Voyager crossed beyond the heliosphere, its instruments detected a sudden increase in high-energy cosmic particles arriving from deep space. At the same time, particles originating from our Sun sharply declined. This confirmed that the spacecraft had entered a completely new environment. But researchers soon noticed something unusual. The intensity of these cosmic rays was not perfectly stable. It fluctuated over time, almost as though invisible waves were passing through interstellar space itself.